right, let's start reviewing for the semester exam. All right, it says label a Venn diagram using the words from the box to show the relationship between the number sets. If you remember from the fall, I had the words never wear ice rings. Okay, so that was the order, something to remember, and that was the order to remember these words. So this would be natural, whole numbers, integers, rational, and then this would be irrational. Okay, natural are your counting numbers, 1, 2, 3, anything that you can count. Whole numbers are 0, and then all your counting numbers. Integers are your negative and positive numbers. Rational numbers are your fractions, decimals, percents. And then irrational are the numbers that the decimals that will keep on going. They don't stop. Okay? For instance, like pi. Pi is one of those. So anything here, if it's a whole number, it can be an integer, it can be a rational. If it's a natural, it's everything up. So wherever it starts, it's everything as it goes out. But it cannot go back in. So a decimal will be here, but it cannot be an integer, it cannot be a whole number, and it cannot be a natural number. But -5 is an integer and a rational number. So whatever it is, it goes out, but not all the way in. Okay? So let's look at these true, false. All whole numbers are rational numbers. Here's whole numbers, and as long as it's going out, it is a rational number. True. All integers are rational numbers. All integers are rational numbers. Yes, true, because it's right here and it goes out towards the rational. All rational numbers are integers. All rational numbers are integers. It cannot go back in, so that one's false. All integers are whole numbers. All integers are whole numbers. No, it cannot go back into the circle. All natural numbers are whole numbers. Natural are whole numbers. Yes, because it works its way out. Rational numbers can be terminating and repeating decimals. Yes. And square root of 7 is a rational number. Put that in the calculator. And that is false. The square root of 7 is yes, that is false. It is an irrational number. It is an irrational number. Okay? All right, 5/7. We're going to label these. So 5/7, 0.7426. This one's going to be rational. -5. -5 is an integer. And it also can be irrational. And I'm just going to put a small check mark there because it can be 1, 2. 0, it's a whole number, but it can be an integer and it can be a rational number. The square root of 5 is an irrational number. 14 is a natural number. It can be a whole number, and it can be an integer, and it can be a rational number. -2/3 is a rational number because it has a decimal. 0.65, it is a rational number, and then pi is an irrational number. Which letter on the number line represents the value of 7, a square root of 7. So the square root of 5 is 2.23607. The square root of 7 is 2.64575. Okay? So which letter on the number line represents the value of square root of 7 and the value of square root of 5? So okay, technically 1 should be here, this should be 2, this should be 3. So since these are both bigger than 2, it can't be that one. And it's less, they're both in the, it can't be, these are both 2 point something, so it can't be bigger than 3. So the square root of 5 is 2.2, so that's closer to 2, so, and the square root of 7 is 2.6, so that's a little bit more than half. All right. All right, we're going to do decimal notation. I think that's 9.03. This one we can put in the calculator. 9.03 times 10 to the second is 903. 7.89 times 10 to the third is 7,890. 5.1 times 10 to the negative 2 is 0.051, and 7.7 times 10 to the negative 5 is 0.000077. Okay. Also, too, if I have this one 7, 8, 9, I want to go 1, 2, 3. Okay, this one 5.1, because it's negative, I'm going to go to the left. I go 1, 2. Okay, and then same thing here, 7.7. I'm going to go 5 to the left. 1, 2, 3, 4, 5. Okay. All right, it says look at the table. Which of the following represents the same relationship between x and y? Y equals 10x. So 10, 1, 10, 1, 10, 1. Remember, delta y over delta x equals 10 over 1. So that's good. A person can earn $10 an hour. If this is 20 and 2, 20 divided by 2 is 10. So a person can earn $10 an hour, okay. Hmm. 10. So it can be 1, 2, and 3. So this one can earn $10 an hour. So the graph says it's $10 per hour because we divided 10 divided by 2. If I did 40 divided by 4, that's going to be that too. Y equals 10x. Yes, these are 10, these are 10, and then a person can earn $10 per hour, and then remember that per, that is 10x. So 1, 2, and 3. Cameron works at a car dealership and makes a monthly salary of $1,750 plus a commission of $500 for every car he sells. Which of the following equations can be used to determine the amount of money Cameron will make if he sells a specific number of cars? Okay, there's the word plus. Remember, $500 for every, there's that word, remember, P, per, each, every. That number goes with X. So 1,750 plus 500X. Okay, we'll determine the amount of money, M. Cameron will make if he sells a specific number of cars, C. So the C needs to go with the 500 and M has to be with the N part. So the answer is A. Students organized a walkathon as a fundraiser. The graph shows the amount of money earned during this fundraiser. Which best describes the amount of money raised per mile? The students raised $900 per mile. Let's see, this is 700 divided by 4. I know the picture is not good. This is 700, and 700 crosses exactly at the 4, so I'm going to go 700 divided by 4, and that equals 175 per mile. So remember, you want to look at the graph and see where the line, this side and this side crosses exactly at the line and at the corners to get an exact amount. So that is C. What is the slope of Vx and Xz? Okay, as long as these triangles are connected to the line, they're going to have the same slope. So we're going to do rise and run. So 1, 2, 3, 4 over 1, 2. So 4 over 2 is 2. And then 1, 2, 3, 4 over 1, 2. 4 over 2 is 2. So I did the rise and I did the run, and then I put it in and I reduced the fractions to 2. So the slope is 2 of both of them.